Okay, let's have a look at this question. It's a tricky enough question. So if you try and do it yourself and then have a look at the video and see how I do it. So we've got to find the equation of the tangent to the curve y is equal to tan inverse 2x plus 1 at x equals 0. So first of all, we've got to find the equation of the tangent. So a tangent is just a straight line. So the equation of a tangent is the equation of a line. So it's going to be y minus y1 is equal to m by x minus x1, where x1 and y1 are a point on the curve. So we don't know what the point is. We know that the x value is 0, but we don't know the y value. But we can find that out by just subbing x equals 0 into this equation, and then we get y is equal to. So we'll be able to find x1 and y1, and m is the slope of the tangent. And we remember that the slope of the tangent is the same as the slope of the curve. Okay, so let's first of all find out when x is 0, what is the value of y? So when x equals 0, then y is equal to tan inverse 2 times 0 plus 1. So to find out what y is, I'm just filling in x equals 0 into this equation here. So x equals 0, y is equal to tan inverse 2 by 0 plus 1. So I have y is equal to tan inverse 2 by 0 is 0 plus 1, so tan inverse 1. So tan inverse 1, I get y is equal to, in radians, I get pi over 4. So when x equals 0, y is equal to pi over 4. So this is our point. It's the point x is 0, y is pi over 4. Now if you don't remember, pi over 4 is 45 degrees, and in radians it's written as pi over 4. 45 degrees is pi over 4. So here's our value of x1 and y1. So x1 is 0, y1 is pi over 4. So we can fill them into here and here. So I'll just write here, this is x1, y1. So I just put a star beside that because we're going to come back to that. Okay, the next thing we need to do is we need to find the slope. We need to find the value of m. So this is what we really want at the very end. We're going to fill everything into this. We know x1 and y1 now, and now we need to find the slope. We need to find the value m. But the slope of the tangent is the same as the slope of the curve. So we're going to find the slope of this curve. So we need to find dy over dx. And this is the tricky part because I need to differentiate this. We have our rules for differentiation for inverse trigonometric functions over here. So tan inverse x over a differentiates to give us this. We can put this over 1, so we have the a part, it's over 1. We can always put it over 1. But in order to differentiate this, we're going to have to use the chain rule because we've got a function inside a function. We've got one function is the 2x plus 1 part, and the other function is the tan inverse part. So we're going to have to use the chain rule on this. So let's write down, okay, let's say f of x is equal to 2x plus 1. So that's the first function. And then let's say g of x is equal to tan inverse. And it's tan inverse 2x plus 1, but 2x plus 1 is f of x. So it's tan inverse f of x. And I'm going to put it over 1 just so it looks like this over here. It's something over a number. So we have f of x over 1. Now each part of these are easy to differentiate. So here I can find f dash x, differentiate this and I get 2. And then g dash x, differentiate this. I can just use this rule over here. The x part is this part, it's f of x, and the a part is 1. So g dash x is going to be 1, so a all over a squared, so 1 squared, plus the x part squared, which is the top part, the numerator in the fraction. So it's f of x squared, so 1 plus f of x all to be squared. And I can fill in now what f of x is. So I can tidy that up. I get 1 over 1 plus, well, f of x we know is this, it's 2x plus 1. So it's 1 over 1 plus 2x plus 1 all to be squared. And now by the chain rule, we know that dy over dx, so this differentiated, dy over dx is going to be equal to f dash x. So if you can't remember how to do this, if you go back and have a look at the chain rule videos. So dy over dx will be f dash x, so this multiplied by this, so times g dash x. So that is equal to, f dash x is 2, so it's just 2 times g dash x is this, so 1 all over 1 plus 2x plus 1 all to be squared. Okay, so that's dy over dx. And if you remember, dy over dx means the slope. So dy over dx is the slope of this curve up here, but the slope of the curve and the slope of the tangent are the same. So we want to find out the slope of the tangent when x is equal to 0. So when x is equal to 0, we can find dy over dx. So dy over dx will equal twice, and just fill in 0 for x in this. So twice 1 over 1 plus, and it's going to be twice, there's an x there, so I'm going to fill in 0, plus 1 all to be squared. So dy over dx is equal to twice 1 over, well, 2 by, it's 1 plus, so 2 by 0 is 0, plus 1 squared, which is 1 squared is 1, so that's twice 1 over 2, which is just 1. So when x is 0, dy over dx, so x is equal to 0, so when x is 0, when x is equal to 0, dy over dx is equal to 1. So now we know the slope. We know the slope, and we know the points x1 and y1. So the equation of the tangent of the curve, here's the answer up here. Y minus y1, write it down again, y minus y1 is equal to m, which is the slope, by x minus x1. So I fill in y minus, well, y1 we've already figured out up here, it's pi over 4, is equal to m, which is the slope, which we figured out down here, which is 1. So 1 by x minus, and x1 is this point here, it's 0. So 1 minus 0, so I have y minus pi, x1 is 0, yes, sorry. So we have x1 is 0, so y minus pi over 4 is equal to 1 by x minus 0, or just wrote the same thing again, sorry. So we have y minus pi over 4 is equal to 1 times x, or just x, or we can rearrange that to get y is equal to x plus pi over 4. And that's the answer, that's the equation of the tangent to this curve when x is equal to 0.